Good day everyone. Our topic for today is all about trigonometric substitution involving a² minus u² part 2. In part 2, example is the integral of x² times the square root of a² minus x² dx. Let x equal to a sine of theta, so that dx is equal to a cosine of theta d theta, and remember we have x² term here, so x² is equal to a² sine squared of theta. So let's substitute everything that we have here. We have the integral of x², which is a² sine squared of theta. There, the square root of a² minus a², which is a² sine squared of theta. We have the x as a cosine of theta d theta. So we have a² here and we have a here. So this can be simplified into a³ integral all sine squared of theta times the square root of a² minus a² sine squared theta. Then we have a² as common term. We have a² times 1 minus sine squared of theta, and then we have cosine of theta d theta. The square root of a² is simply a, and then we have a³ here, so we have a to the 4th here times sine squared of theta, and remember that 1 minus sine squared of theta is cosine squared of theta. So the cosine squared of theta, the square root of that is cosine of theta. Then we have here a cosine theta, so this is sine squared of theta, cosine of theta d theta. So this can be rewrite as the integral of sine of theta cosine of theta square d theta. And then remember, in the left side, note that sine of 2 theta is equal to 2 sine of theta cosine of theta, so that 1/2 sine of 2 theta is equal to sine of theta cosine of theta. We can replace there, or we can substitute it here. So we have see that this is a raised to the 4 times the quantity 1/2 sine of 2 theta squared d theta. Then we have simplified, and the cosine of 2 theta as cosine squared of theta minus sine squared of theta. So we have 4 sine of theta cosine cube of theta minus of sine of cube of theta cosine of theta. So it means we substitute it here. We have a to the 4 power 4 power over 4 over 8 times theta minus 1/4 sine of 4 theta. So this one is sine of 4 theta. So if you multiply this by 1/4, so we have minus sine of theta cosine of 3 theta, and this will become plus sine cube of theta cosine of theta plus c. So we need to determine the value of cosine of theta. So again, by drawing a right triangle, this is theta, so cosine of theta is x over a. So this is x and this is a, making this one square root of a² minus x². So that cosine of theta is equal to adjacent, which is the square root of a² minus a² divided by hypotenuse, which is a. So If we substitute of here, so a raised to 4 over 8 times theta, which is the arc sine of x over a minus this is sine of theta, so that is x over a, and then cosine cube of theta is plus 1 cube, so write it as a squared minus a squared raised to 3 halves divided by a cube plus sine cube of theta. We have x cube over a cube there times cosine of theta, which is the square root of a squared minus x squared, so write it a squared minus x squared raised to 1 half divided by a plus c. So we have a to the 4th power over 8 times arc sine of x over a minus we have x times the quantity of a squared minus x squared base 3 halves all over a raised to 4th plus x cubed times a squared minus x squared raised to 1 half divided by a raised to 4 plus c. So if we want to substitute or distribute a raised to the 4 over 8, so we have a raised to 4 over 8 x sine of x over na a minus x times a squared minus x squared raised to 3 halves all over 8 plus 8 cube of x squared minus x squared raised to the 1 half all over 8 plus c. So this will be the final answer in this problem number 2.